Gold has been used in both jewellery and as a form of currency from the very early stages of civilization, and is still being used for these purposes today. However, gold is now also being used in many manufacturing processes and electronic devices, especially in mobile phones. So what is it about gold that such a valuable metal is used in the creation of these items? Well, gold has an atomic number of 79, resists corrosion or reaction with most other chemicals, including almost all acids. In addition, gold is extremely ductile. It means it can be made into very thin wire or spread out into flat sheets called gold leaf, only a few atoms thick. As well as this, gold is a very good conductor of electricity. It means that gold can be used in many electronic devices, especially those which have parts which are exposed to the elements. Some of these electronic devices may rely on tiny voltages and currents passing through certain parts of their systems, including connectors, switches, and relay contacts. These parts become corroded or tarnished in any way, the whole device may cease to function. So some of these connections are made using gold. But since gold is so ductile, only a tiny amount of gold is used in each electronic device. Now currently, approximately 10% of all the gold being mined is now being used for industrial purposes, making electronic devices. This number is only likely to increase as a wider variety of items are created and more people use them. However, because some of these items have a relatively short lifespan, each of these has such a tiny amount of gold in them, it's extremely difficult to recover gold in items like mobile phones, which contain far less than $1 worth of gold. However, since there are now over 1 billion phones constructed each year, all the phones together represent a huge amount of gold and other valuable metals and resources that in many cases not being reused at the end of their life. One of the challenges our society faces is how to safely and efficiently recover the resources that are locked up in these devices, not just discard them. The question of recovery might be resolved by automation. The same way these devices are built by robotic means, may be that they can be disassembled by them and the useful items that are locked away efficiently recovered, possibly by requiring the manufacturers to also be able to deconstruct their own devices.